solve the question Leetcode daily challenge. So the question is the maximum point you can obtain from the cards. So what we are given in the question, we are given the array and the value of k. So we have to obtain three cards. So three cards हमें उठाने हैं. That is we have to pick cards from the beginning or the end. We either pick from the beginning or from the end. We have to pick three cards such that there is at every card there is a card point written. So every card has an associated number of points. The points are given in the integer called card points. So this is the array that is given to us. In one step you can take one card from the beginning or from the end, and you have to take exactly k cards. So हम beginning से भी उठा सकते हैं, beginning के k cards उठा ले, ठीक है, एंड के के कार्ड्स उठा ले, या दो यहाँ से उठा ले और जो बच्चे कुचे हैं वो एंड से उठा ले, या फिर यहाँ से एक कार्ड उठाए और जो बचे हुए हैं वो यहाँ से उठा ले. तो हम ऐसा कर सकते हैं, बट वी हैव टू पिक आइदर फ्रॉम द बिगनिंग और फ्रॉम द एंड. ओके, दिस वी हैव टू डू. एंड द स्कोर your score is the sum of the points of the cards you have taken. So the score is the sum of the points that is given in the on the cards, and we have to maximize the score. So we have to maximize the score. So the value or the card which we choose from the beginning or the end should give us the maximum output from the cards that we pick from the beginning or from the end. So let us analyze for the given card points array. So we have the array 1, 2, 3, 4, 5, 6 and 1, and k is 3. So हम तीन कार्ड उठा सकते हैं, या तो हम बिगिनिंग से उठाएं या तो फिर हम एंड से उठाएं, बट हमें बिगिनिंग और एंड से उठाने हैं. सो लेट सपोज अगर हम के कार्ड्स यहाँ से उठा लें, मतलब तीन कार्ड्स यहाँ से उठा लें, तो हमारा जो कार्ड पॉइंट्स का सम होगा वो कितना होगा, 6 होगा. सो द सम विल बी 6. Okay, if we choose the k cards from the beginning, all the k cards from the beginning, then we have, for the current array we have the sum as 6. Then we remove this one and add this ending card into our sum, and we find our sum. The current sum is 4. Is it maximum? No, it is not. The maximum till current situation is 6. Then what we can do, we can add, we can remove this one also and add this one. So now our selected cards are this one, and this one. So the sum is 8 in the current case. So it is greater. So the maximum sum is greater. The sum is 8. Then we remove this card also and add this card. So for this, the sum would be 12. The sum is 12, and what we'll do, it is the maximum sum now. From these all sum, it is the maximum sum, so we'll return this maximum sum. We have to return the sum now. Yeah, we have to. So as we can see, the maximum sum is 12 in this case, which we have got, and here also the sum is 12. Let us analyze for one more test case to make it more clear. तो अब इसके लिए देख लेते हैं 9779779. Okay, so this is the array. The value for k is 7. So अगर हम देखें तो 7 तो इस कार्ड पॉइंट का साइज है ही. तो पर्टिकुलरली हमें इस सिचुएशन में, तो जब हम यहाँ से ऐड करेंगे ना, यहाँ से k एलिमेंट्स ऐड करेंगे, so we are taking the sum of all the elements of the array, so it will be 55. Then we remove, what we will remove this, the ending one, and what we will be adding, this one. So basically we will get the output as 55. Okay. So this approach, we look at this approach as we look at the first approach, solve the problem. So in this approach, what we have to do, we first have to add or sum the first k elements. First k elements. Let me zoom a bit. Okay, so that the steps of the first approach would be clear to you. First, what we will do, we will add first k characters. That is, if this is the array, this is the array, and the k value is 3, so we'll add the first three characters, uh, first three elements of the array. Okay, then what we have to do, once we find the sum of first k elements, then we'll run a loop for I equals to 0 to i I less than k. Okay, that particularly means we have to run a loop k times, and what we have to do, for every time we will subtract the k minus 1th, that is this element sum. We will subtract this element sum, and what we will do, we will add this one. Okay, so this step is basically doing the same thing. We will remove the k minus 1th element and subtract its contribution in the sum, and add the n minus 1th element to the sum. Okay, and we'll also maintain a variable that stores the maximum sum that we can obtain, and each time we gonna update its value based on the current sum. So its value here would be 6. Then when we got this value, that is the maximum value, then its value would be 12. Okay, here it would be 6. So a maximum value, a variable that stores the maximum sum, and for every iteration we'll check if the current sum is greater than the maximum sum or not. If the current sum is greater than the maximum sum, we're gonna update the maximum sum, otherwise we don't gonna update it. So this approach requires, first I will show you the code. Okay, I will show you the code for this. Okay, so we'll run a loop, we'll run a loop. Yeah, we run a loop from that. The variable is, we have renamed the variable as b. So we are running the loop from I equals to 0 to b to find the sum of the first k or b elements. Okay, then we are maintaining a variable that stores the maximum sum that we can obtain from the k segment from the beginning or the end. So what we are doing, we are we are running the loop for k times, and every time what we are doing, we are subtracting b minus, oh, b minus 1 minus ith element. That is what we are doing, this one. And we are adding, this is just cropped. Okay, so what we are doing, we here are adding a a dot size minus 1, that is basically n minus 1 minus I. Okay, so this is what we are doing at, and at every iteration we're gonna update if the maximum sum, if the current sum is greater than the maximum sum, and at the end of the iteration we'll return the maximum sum. So this approach will take the time complexity of order of 2k, and depends on k, and space complexity of order of 1. So this is one of the possible approach to solve the problem. Now we will look at one more approach to solve this problem. Okay. Now we look at the second approach to solve the problem. So what we have to find, we have to find the sum of k elements that are starting from the beginning or the end. So first case, we are taking all the elements, kth elements from the beginning. So the remaining elements should be these that are highlighted in the green. Just analyze what I am trying to say. For the second case, if we take the two elements, if the k value is 3, if we take two elements from the beginning and one element from the end, this is one of the possible case. Then the remaining elements should be these that are highlighted in the green one. Similarly, in the case 3, this is one of the possible case. So here when we select one element from the beginning and two elements from the end, so it is one of the possible case. We look at the remaining element, so these form a subarray of size 4. Here also we form a subarray of size 4. Here we also have a subarray of size 4. The next possible case is if we select all the elements from the end, then the remaining elements also form a subarray. So what I'm trying to convey here is the remaining elements from these selected elements form a subarray, and to get the maximum out of these k elements, we have to find the minimum of these n minus k elements. Okay, and these form a subarray, so we can apply the sliding window approach to find the minimum sum subarray of size n minus k. So this is what I am trying to convey using these cases, that if we analyze all of the test case for this particular test case, we analyze all the particular cases. If we select k from the beginning, that this is the particular subarray. If we select 2 from the beginning, 1 from the end, this is the particular subarray. If we select 1 from the beginning and 2 from the end, this is the particular subarray. If we select all from the ending, then this is the particular subarray. We have to find the minimum sum of these subarray, and what we have to do, we have to subtract it from the total sum of the array. Okay, so now I move to the algorithm. So after analyzing case 1 and 2, 1, 2, 3 and 4, we can say that to get the maximum sum of k elements, we have to find the minimum sum of k minus n minus k size consecutive subarray that we have analyzed, because its size is k n minus k. Okay, which can easily find using the sliding window approach, because we can easily find this one using the sliding window. If you haven't have the idea of sliding window, so I suggest you to first uh, look up on the sliding window technique and then continue in this video. Okay, now what is the algorithm to solve this problem? We'll calculate the sum of all the elements of the array. Okay, we calculate the sum of all the elements of the array, and after that, using the sliding window approach, we'll try to find the minimum subarray sum of subarray of size n minus k. That is simple if you know the sliding window approach. Okay, so after computing both the values, we'll subtract the value, that sk value, because it would be minimum, it would be less than sk value will be less than s, so we'll subtract sk from s. Okay, and this particular will be our answer. Okay, now we look at the code for this, what I have said, what the algorithm is said. First thing is we have to find sum of all the elements. We have find sum of all the elements here. Now for the window size, we are applying the sliding window approach here. Okay, we have the window of size a dot size minus b, that is particularly we have renamed it as b. Okay, we have the window size as k. If the window size is equals to 0, that particularly means we have to return the whole sum. That is the case when we have the k value as the is equals to n. This is the particular case, that the b value, in this case, if the b value here given is equals to the size of the array element, then if we subtract this from this, then we got the value of k as 0. At that particular case, our window is of array size. We'll return the sum of the array. Then we'll apply the sliding window technique here. Okay, this I'm not going to explain because I will look forward to it. If you already know the sliding window, it would be easy for you to understand. We have the two pointers. We'll maintain until we reach the window size. We'll increase our size and add it to our sum. This is what we are doing. Okay, when we have reached the size, then what we have to do, we just uh, subtract the window start after computing the minimum sum. We are maintaining a global variable that contain global variable, not we are using a variable that maintain the minimum sum till this point. Okay, till this point it maintain the minimum sum, and this particular variable will give us the value of sk here. Okay, so if our window size will be reached, we'll compute this, move our window to the next point, because the sliding window approach move this way. Because 1 second, if we have the window of size 3, then if we have the window of size 3, then we deduct this value, we add this value. Okay, we deduct this, add this. So this particular thing we are doing here, we are subtracting this value, that is the ith index, that is the window start. So this is how we will find the minimum sum subarray, and after finding the minimum sum subarray of size n minus k, what we have to do, we have to return the result of the subtraction of the sum of all the elements and the minimum sum subarray, okay, of size n minus k. This is what we have to return. Okay, this approach requires a time complexity of order of 2n, because to find the sum of all the elements we require n time complexity. For this sliding window approach, we again require order of n time complexity. So we have order of 2n, and the space complexity is constant space complexity order. So this is one of the possible approach. So after analyzing both the approaches, I think if the value of k is less than n, then the above approach that works on order of k time complexity is better. And if k is greater than n, that cannot be the case. If k cannot be greater than n, so that particularly means the previous approach is nice. Okay, previous approach is good. Okay, so if you have any doubt, please feel free to ask, and I have shared a link in the description of the code and the question. Okay, bye.